Hello everyone, let's talk about timetables. Timetables may be the first thing that a train passenger checks while they're planning their journey and onwards connections, and in the past, this was a complicated process, cross-checking paper timetables. Fortunately now the process is smoother, with journey planning readily accessible online. But a lot of effort goes into creating and optimising timetables to help the railway run efficiently. Let's take a look at the process of creating a timetable and some of the decisions and trade-offs involved in this. In the UK, the process begins around 18 months before the timetable comes into operation, with passenger and freight operators submitting bids for what services they want to run. Network Rail then coordinates and validates these services together to form the timetable according to a set of documents called the Timetable Planning Rules. These specify parameters such as sectional running times, headways and dwell times for every station and section of track in the network. Planners must also consider the trade-off between maximising capacity and maximising efficient resource management, not just of rolling stock but of train crew too, including movements to and from the depots at the start and end of each day. Activity at junctions can be challenging to optimise in the timetable. Generally, planners try to schedule parallel movements, where trains pass through the junction in opposite directions simultaneously without getting in each other's way. And planners try to avoid conflicting movements, where some trains passing through the junction block other trains from continuing. Where this is unavoidable, pathing time must be added to the timetable, where a train service waits at a junction for a clear path to continue. Planners may fix a key point in the timetable, such as movement through a congested junction or turnaround time at a busy terminus, and then extrapolate the rest of a train service around this. Then other train services that interact with this can be planned logically around it to prevent conflicts. Network Rail bring all these factors together to create a network-wide working timetable, which schedules every train movement, including passenger, freight and empty rolling stock movements. This timetables both station calls and passes through other waypoints such as junctions at half-minute increments. As you can imagine, the magnitude of this task is enormous due to the complicated nature of an interconnected network. Since the 1990s, computer algorithms have been used to aid timetable planners. For example, in 2007, the Dutch rail network implemented a radical route-wide timetable overhaul using the DONS algorithm. This led to a noticeable increase in ridership by providing more trains with increased punctuality thanks to the optimized timetable. On a mainline railway, it can be very challenging to balance the needs of various types of services. Timetables can be represented with a time-space graph like this. Note the difference between express trains, local passenger trains with more stops, and freight trains, which may have to wait in sidings or passing loops to give priority to passenger trains. Running a variety of different types of services comes with a trade-off of reducing capacity, as trains cannot all run behind each other at the minimum headway. It is not always possible to accommodate the needs of every passenger due to finite capacity on the existing infrastructure. Here is a real-life example from an internet forum. After the upcoming December 2025 East Coast Mainline timetable changes implemented, a commuter's journey between Grantham and Newark Northgate will no longer be regularly served. This is because the operator, LNER, is adjusting its services to prioritise long-distance intercity travel, adding 16,000 extra seats daily and reducing journey times from London to cities such as Newcastle and Edinburgh at the expense of local journeys. And last year, GB Rail Freight criticised this proposed timetable change too for omitting the Coca-Cola freight train from Wakefield, which can be difficult to fit into the timetable as it doesn't fit into some passing loops due to its length. There's also a trade-off between reliability and journey times. A good timetable must be robust enough to absorb the effects of small random delays and prevent them escalating across the network. However, if the timetable has too much padding in it, train travel may be perceived as slow and unappealing. In the UK, route-wide timetable changes in May 2018 overstretched the capability of the railway and caused widespread disruption as trains could not keep up with the schedule. This was partly blamed on delays to electrification in the northwest and to replanning Thameslink services to London. Finally, some countries such as the Netherlands and Switzerland implement a method called clock-face scheduling, where trains converge on key transfer nodes at fixed intervals, usually on the hour or half past the hour, to facilitate convenient transfers. However, this also comes with trade-offs. Stations require many platforms to accommodate many trains at once, and passengers with reduced mobility may need trains to wait at stations longer to make their connections, whereas passengers remaining on the train without changing would prefer shorter dwell times to reduce journey times. In conclusion, timetable planning is a very complicated process with many interconnected factors that requires many iterations to optimise, but this is key to running an efficient and reliable railway. It's important that passengers can have faith that the train will arrive when the timetable says it will. But it's difficult to manage the requirements of all service types and all passenger needs, so timetable planning inevitably results in trade-offs. Future technological advancements, infrastructure enhancements, and changing travel demands mean that it's important that any timetable has regular incremental revision to keep it operating as efficiently as possible. Thank you for watching.